Hi, I'm going to design a search using an alternate search approach. This uses seed studies and it uses automation tools to build a search. The topic I'll be searching for is blue light to treat acne. To start off with, I'm going to export some seed studies. We set up the group. I have 10 studies here, which are my evaluation set. These are 10 that should be in the view. I've randomly selected 5 to make up my seed set. So I'll export these. We'll come over. I'm going to use the Evidence Review Accelerator to do it. First thing I'm going to do is I'm going to upload that file that I just saved. That's this one here, 5 references. I'm going to import it into the WordFreak tool. I'm going to go down and I'm just going to dig out the words I need, put them into my Word doc, skipping the ones I don't need. Combining population or participant words before intervention words and population words with N. Alright, that's the bottom of the list. So I've separated out all the acne terms that I could find in there, all of the intervention terms or phototherapy blue light terms there. I will add a randomized trial study filter, but I will do that later. So the next thing to do is to try to find some mesh terms. I'll do that by going to the Meshmate tool. Type in my topic. So acne vulgaris looks like a good term. Write that up in here. Did not look like a good term for blue light. I know that phototherapy was another word that was showing up, so I'll try that. Phototherapy looks pretty good. I'll copy that. Add that in as well. So I've got all these words. Now, next thing to do is add quote marks and field codes. So I'll go tab, which means title abstract everything. Quotes around blue light. Brackets then is the next thing I do right at the end. This allows me to run it all as a single search line, and so that's looking pretty good. Next thing I'll do is I'm just going to run it very, very quickly in PubMed, just to kind of make sure it's working and I haven't made any mistakes. In other words, I'm looking for PubMed to tell me whether or not it works or doesn't work. Cool. Although 44,000 is a lot, it looks like it kind of works. So now I'm going to try to figure out a way to refine the search, and I'll do that in the search refiner. So I'll get my PubMed search, head to search refiner, just one, and I'll get the 5 PubMed IDs from my seed set. So I've got an actual filter that will let me do that, but you could just go copy, paste, PubMed ID will be in the accession number field. Or I have a search refiner format. Copy formatted references. This means everything's copied and ready for the search refiner. Alright, so it finds 44,000, which is way too many, but it finds 5 relevant out of the 5 relevant I needed to find. Now, starting on my, let me see, Acme side, I'll see what I can rip out to get a better result. Sorry, this is my intervention side. I guess I'll start here today. I'll try getting rid of LED. Laser also only gets 2 references for 300,000 retrieved, so it doesn't look like a good term either. Let's see what happens there. Right, already starting to get much better. I'm now going to try getting rid of lesions or lesion. Done, 1,362, it's pretty good. Especially since I'm going to add a randomized trial filter onto this anyway. It should reduce it even more. So I'm going to stick this search. So this is my new search that I'm going to be using in translating in the Polydot, which is the next step. So I'm just going to make a note. Alright, so this is my new search. Thinking for this one, we probably want to search Cochrane Central. And Embase. So I'll go to Polyglot. Put my Acme search in. I'll get out the Cochrane Library search. Or Cochrane Central search. Do the same thing. And get out the Embase Elsevier, which is the one that our library subscribes to. I'm now just going to check the entry terms of the Embase search. We've got an entry. Get Acne vulgaris. Alright, so although it's the same, I'll just replace it in case the future one is different. Syntax stays the same. Make sure you don't delete anything else, but just replace the actual word. Is the only thing you need to replace. I'll just grab phototherapy. Do the same thing. Cool, that's good. Oh, I'll even copy it here. Paste it in over the top. Just delete that extra space there. So when I'm done, then I'll get my study design filters, in this case randomized trial filters. So I'll use the ones that I have made myself over many years of experience and time and work. I'll leave off the not section. So this is my PubMed one. Although these filters are based on work done by other people, for the life of me I can't really remember anymore, but this is the Cochrane one, I'm pretty sure. Or based off the Cochrane one. This is the Embase one, and I can't remember what this is. I've made a couple of very minor tweaks, but for the most part they're the same as the original published filters. So I just add them in, and I'm pretty much ready to go. So I'll then create some groups in my EndNote library, and then I will now run these searches. Advanced search for Cochrane, then search manager for Cochrane. I'll just clear my old stuff. I just want the trials. This format for EndNote. Now I'll do Embase. $649 is quite a lot. In fact, just make one small modification to my Embase, which I normally do. I'm just going to add the major subject topic to each of the Embase entry terms. I'll do that by typing /nj at the end of the two mesh terms. This means it will be a major focal point of the article rather than a peripheral or non-focus point. $3.95, it's probably better. I'll now export that. Default format's fine. So everything's ready. Alright, so I will put the PubMed ones in. The central ones. And base ones. And I'll create another group. So this is the one with duplicates. No duplicates, and I'll also split off the registered trials. Put everything in there. Find the registered trials. I'm just going to sort by journal. Find the websites, which is these, HTTPSs. So these will all be registered trials or trial registry entries. Move them over to registered trials, hit delete, then get them out of my search results. And finally, I'm just going to run these through the relaxed version of the deduplicator to get the set from the to screen, also the set that will help me work out the precision or laminated directly. I'll come back to Terra, I'll go to the deduplicator. Make sure that's set to relaxed. blue light with dupes is the set I need to deduplicate. This one, I'll just give it another couple of secs. It takes a little bit of time to process. Hopefully that's long enough. I'll just now put that into the deduplicator. I'll save my results, should be 950. Make it an XML file. That should be this one, the light no dupes. Yep, as you can see, that's the 950, which is the results without duplicates. Alright, and I'll just pull that one and put it back here into the notebook. Input option, this is in a generated XML. As you can see, .xml, so make sure it's set to that. Put the 950 in there. So you can see I've got search results with duplicates, 1398, search results no duplicates, 950, registered files in trees, 69. Then I'll come down to my evaluation set. Mark this as unread. So I'll mark these as unread. So this is the unread field. You can see black dots. So then if I want to find all the ones that are unread, that's in there. So these are all the evaluation ones. I'm just checking to make sure they were found. That was found. So that's found, 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 found. I think that was the last one. Yeah, so you can see all 10 of the studies in the evaluation set. In other words, all 10 of the studies that should have been found by this search for 100% recall were found by this search and achieved 100% recall with a number needed to read of 95. That's it.